Hi viewers, now we discuss the topic exercise 1.4 first question. Without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or a non-terminating repeating decimal expansion. As in the given question, a rational number is given without the actual division. We said that one is it a terminating decimal or a non-terminating repeating decimal. Before going to solution, we choose concept. Decimal expansions are two types. First one terminating, second one non-terminating repeating or recurring decimal. So we observe here, let x be any rational number, that is p by q, where q is not equal to 0, where p comma q are the co-primes, means there is no common factors other than 1. So prime factorization of q, observe here 2 power n into 5 power m, where n comma m are the non-negative integers, that is nothing but as whole numbers. Clearly x equals to p by q is a terminating decimal expansion. Now we check it non-terminating, repeating or recurring decimal. Let x equals to p by q, where p comma q are the co-primes, and prime factorization of q is not equals to in the form of 2 power n into 5 power m, where n comma m are belongs to non-negative integers, that is whole numbers. Clearly here x equals to p by q is a non-terminating repeating decimal. Now we choose note. As in that denominator q conversion as into the purely 2 power notation or 5 power notation or the combination of 2 power n into 5 power m is there as in denominator. Clearly that is a terminating decimal expansion. Now we start the solution. Given that p by q is a rational number that equals to 13 by 3125, we mention that equals to 13 by 3125 prime factorization as 5 power 4. So prime factorization of q can we express as 2 power m into 5 power n. Now how is it like? We check it. So 5 power 4 equals to, can we treat as 5 power 4 into 1. We know that a power 0 equals to 1. Clearly 2 power 0 also equals to 1. So prime factorization of q is in the form of 2 power m into 5 power n. Clearly 13 by 3125 is a terminating decimal. Now we take it one more solution. Given that a rational number we choose as p by q that equals to 17 by 8. So here the prime factorization of 8 can be treated as 2 power 3. So 2 power 3 indicated by that as 2 power 3 into 1. We know that a power 0 equals to 1. Clearly, similarly 5 power 0 equals to 1. Now in the place of 1, what we substitute? 5 power 0. Therefore p by q equals to 17 by 2 power 3 can be treated as 2 power 3 into 5 power 0. Prime factorization of q we get like as in the form of q equals to 2 power m into 5 power n. We observe here q value as it 2 power 3 into 5 power 0, that is nothing but q value equals to 2 power m into 5 power n. So 17 by 8 is a terminating decimal. Now we take it one more solution. Given that p by q a rational number indicated like 64 by 455, that equals to 64 by 455 prime factorization we treated as 5 into 7 into 13. So prime factorization of q is not equals to in the form of 2 power m into 5 power n. Yes, q is not equals in the form of 2 power m into 5 power n. Therefore 64 by 455 is a non-terminating repeating decimal or recurring decimal. Now we take it one more solution. Given that a rational number p by q equals to 15 by 1600. In both numerator and denominator common multiple is 5 is there. So 5 3s are 15 and 5 320s are. So prime factoration of 320 can be treated as 2 power 6 into 5 power 1. Prime factoration of q equals to 2 power m into 5 power n. Therefore, the required 15 by 1600 is a terminating decimal. I hope to understand this solution. Thank you for selecting my video.